Okay, students, we are on page 171, topic 2, topic 3, lesson 2 of mod 1, ASA, SAS, and SSS. So go ahead and pause the video and do the warm-ups here. Your choices are rotation, translation, or reflection. So figure A is the pre-image, and so number 1 is asking how to get to B. That would be a translation, just slid down. How do you get from A to C? That would be a reflection over that line. Or to do that, you find the midpoint, two corresponding midpoints. So if I take that point, find the midpoint, that point, find the midpoint, and there's my line of reflection. And lastly, from A to D is a rotation. Now, you can see that this, for example, right here, rotated all the way around. So now it's facing down right there. Okay. All right, go on now. Okay. So congruent corresponding parts. This is vocabulary. How you identify corresponding parts. If I have one arc here, I look at somewhere else, I have one arc, that means those two are congruent. Angle A is congruent to angle F. Okay. Now remember, they, instead of saying A is congruent to angle F with one letter, because there's only one angle there, they chose to use 3 letters. Remember, the middle letter is the angle. There's A, there's F. Now notice they have another angle here, B. If I look right here at B, it also has only one arc. So that means all 3 of those are congruent. If I have one arc, wherever else I have one arc, they're congruent. Those are called corresponding parts, or congruent corresponding parts. All right, so here now we're talking about angle B and angle D. Okay, now with angle B, I can't call it angle B anymore because there's 3 different angles here. This angle, and the entire angle. So that's why I couldn't go ahead, whereas angle A, there's only one angle there. Angle F, there's only one angle there. So I could have said A and F there, but on B, there's 3 potential angles. That one, it's got the 2 arcs, that one's got the one, and the entire one for a total of 3 different angles there. So I have to use 3 letters. Remember, that's always the safest way, which is why they had to use 3 letters for this one right here. They could not have said just angle B there. All right. So again, since we're dealing with vertex B, I have 3 angles. I have to be specific. So ABC is that one right there with the 2 arcs. Well, where else do I see 2 arcs? Right there at angle D. But of course, there's multiple angles there at angle D as well, so I have to use 3 letters. FDE. Again, D being the vertex angle. Okay, so now I can see that those 2 angles are congruent. And then, so that's for angles, we use arcs to show which ones are congruent. For sides, we use hash marks. So one hash mark there, one hash mark there means those 2 sides are congruent. AB is congruent to FD. And then here we have 2 hash marks and 2 hash marks. So those are congruent. BC to DE, both congruent. Okay, so what we want you to do here is to do the same idea. Do problems 1, A and B here. Identify, just like above in that example, the congruent pieces. Okay, by the markings. Go ahead and hit pause. And when you've done your 2, go ahead and hit play again and check your answers. Okay, so to explain, we see one arc there and one arc there. Notice I use 3 letters because each point D or vertex D, I have 3 different angles. Z, I only have 1, but because I have 3 at D, I went ahead and used 3 at Z as well. This segment congruent to that segment, so TD is congruent to DZ. Over here, since there's only one angle there and one angle there, I used angle R is congruent to angle W. Here again around vertex X, I have 3 different angles, and same with T, so I had to use 3 letters. WXT, so I went from there to there to there. So I have to do the same corresponding order. R, T, X. I could not go out to S since I didn't go out to B on the other one. Okay, I could have called it RTS. So this is RTS as well. If I went all the way out to S. But if I did that, I'd have to go all the way out to B down here. So over here, it would have been WXB if I'm going to use that. So it's one or the other. Okay. You can't combine one from up here with one from down here. That's illegal. So it's either the top line or the bottom line right there. All right, next page. Isometries. Remember we talked about isometries. It's the same thing as rigid motions. You gotta remember those are the same, mean the same things. So isometries preserve distance and angle measure. That's the big thing they want you to know in the DCAS. So the lengths are the same and the angle measures are the same. Remember, all isometries or rigid motions are congruent, which means same size and shape. In order to be the same size, you gotta be equal lengths. That's your distances, and to be the same shape, it has to be equal angles, measures. Correspondingly, okay, you can reflect any point in the plane across a line to map onto another point in the plane. A point is equidistant from 2 other points if and only if it lies on the perpendicular bisector. That's the perpendicular bisector theorem. Any point that lies on the perpendicular bisector is equidistant from its endpoints. Now I go to page 177. Okay, so now we get to our 3 proofs here. Side, side, side. Okay, SSS, all 3. So I have a triangle, another triangle. That is congruent to that, that's congruent to that, and that one is congruent to that one. So it's SSS. All 3 corresponding sides are congruent. Another thing we have within proofs that we'll get to eventually is called CPCTC. Corresponding parts of congruent triangles are congruent. So one way of proving triangles congruent is by SSS. That means the other corresponding parts that aren't marked yet are also congruent. So that means this angle is equal to that angle. This angle is equal to that angle, and that angle is equal to that angle. That justification or reason to be able to say that is CPCTC. As it says, is often used as a reason in proofs. Okay, it can only be used after proving 2 triangles congruent, not beforehand, or not to prove them congruent. You can only use this reason after you have proven the triangles congruent, as I just said. Okay, next page. Side angle side. So here's an example of side angle side. Side, an angle, and a side. Side, angle, side, SAS. Okay. We'll look at the actual definition of it probably on the next page here. That's just an example of the drawing. Okay, so here is the definition for side angle side. And these have been on the DCAS before, knowing what this definition is. Of course, it's multiple choice too. Okay, so side angle side, SAS. The angle is in between the 2 sides. Well, that vocab word for in between is included. They want to say, you know that. So if 2 sides and the included angle, or the angle in between them, of one triangle are congruent to 2 corresponding sides and the included angle of the second triangle, then the triangles are congruent. So included means in between. You need to know that. Okay, there's more examples of SAS right there. Okay, angle, side, angle. Okay, notice the S is in between, so the side is included or in between the two angles in this case. So notice we have an angle, a side, and another angle. Angle, side, and another angle. Okay, A, S, A, S, A. The side is included. There's an example, look at the theorem right here. Two angles and the included side. The middle letter is the included one. Of one triangle are congruent to the corresponding two angles in the included side of the other, then they're congruent. So now go to page 183, 3 pages ahead. Okay, so we see that word included in both those. Okay, now you need to be able to do 1A here. 1A and B are the same thing. I'm just going to do it one time with A. Just B is the same thing with different letters. It says draw two triangles that correspond with each congruent statement. Then list the 6 pairs of congruent corresponding parts. So if I just draw 2 congruent triangles, make them right triangles, call it C, G, B to J, M, V. So 6 pairs of congruent corresponding parts. So we have 3 angles and 3 sides. You got to list all of them. Remember, I can get the angles right there. Angle C is congruent to angle J. Angle G is congruent to angle M. And angle B is congruent to angle V. Okay, so there's your 3 sides, 3 pairs right there. I'm sorry, 3 angles. Okay, put it right here, 3 angles. Now we need our 3 sides. Okay, so CG, segment CG, is congruent to segment JM. Go in the exact same order. First 2 and first 2. Let's go second 2, GB and MV. And then we'll go first and last, CB. Segment CB is congruent to segment JV. Okay, the key is you put them in the same order on both triangles. So there's your 6 pairs. 3 angles and 3 sides, 6 pairs. Okay, you gotta be able to do that on the test as well. All right, that ends this lesson.